Hi, I'm playing a game called Canyon Flight, which is a super simple game which I made about an hour ago for our APSU coding camps. It's a super simple game. You can make it as easy or as hard as you like. And I'm going to show you how to make it now. All right, let's begin. So the reason why I've called this Canyon Flight 3 is because I've already made this game twice before. This is a 2D game, and let's begin. Alright, now that we've got our project window open, let's create the necessary folders. We are going to need a folder for scripts, and we are going to need to create a folder for prefabs. Great. Next up, let's import some game assets. I wish to create a spaceship scene, so let's get a spaceship. I want this to be a 2D ship, and I want the pricing to be free. Oop. There we go. Now the one that I've picked out for this particular game that I used is this one right here. You can see that we pull from this one. I'm not going to be using the projectiles that come with the ship, but let's go ahead and import this. All right. After we import the ship, let's go ahead and get the ship into our game. So if I go to the 2D pixel ships, 2 small ships folder, I go to prefabs, there is a ships folder. Let's get, you can use either one you want, it doesn't really matter. I like to get this one, and I like to put it on our Cartesian plane at 0, -1, -2, -3, -4. So at 0, -4. So I just did that with my mouse, and I'm going to fix my coordinates so it really is at 0, -4 in the transform. Now you'll notice that if I'm going to hold the control key and zoom in, my ship is upside down. So to fix that, I'm going to change the Z rotation to -180. Actually, I can just do 180. There we go. And I'm going to rename my ship from ship 1 to just ship. There we go. While we're here, I would like for you to add some components to the ship. First, let's go to Physics 2D and get a Box Collider 2D. Make sure that you select that this is a trigger. So is trigger. Next, we are going to add a component, Physics 2D, and we are going to get a, I believe it's a Rigid Body 2D. Once you get Rigid Body 2D selected, make sure that the body type is kinematic. Next, we are going to add a script. So let's go to Add Component. New scripts are at the very bottom, and then we select Ship, because this will be a script for our ship. Now, I would like to move the ship file into my scripts folder. And this is purely for housekeeping reasons. All right, so there's our ship. Let's double click on ship and bring it up. All objects within Unity that move need to have a speed. So we'll do public float speed, and let's use 5.0 f. Now whenever you add a public variable to any object, notice that we called our public variable speed. Whenever I look at the ship in the inspector, and I scroll down to the bottom, you will see that ship, the script block, has a speed set to 5. And that's because I just set speed to 5 right here. What we need to do now is to get the compute the movement. So we are going to change the x-axis so that the ship moves back and forth. So float x is equal to input.get axis horizontal times speed times time.delta time. Now what input.getAxis horizontal do is it will apply a -1 to the left key or to the A key on your keyboard, and it will apply a +1 to the right key or the D key on your keyboard. So if you have a preference for moving left and right with A and D, or if you have a preference for moving left and right with the left and right arrow keys, this will work either way. All right. Now that we've computed our x, we need to add that to our current position. Transform.position plus equals new vector 3 x 0 and 0. All right. So let's go and play our game. Check the console to see if you get any error messages. And if you do get an error message, go back and check the code. When we play our game, the ship should move left and right. Notice that whenever I hit the up and down keys on the keyboard, or the W and S keys on the keyboard, the ship does not move, and that's because we did not program anything for input get axis vertical. But we did do left and right, and so I'm hitting A and D on my keyboard now, and the ship moves. I'm going to pause to figure out what it is I need to do next. For our next portion, we are going to get the score to appear in the corner of the game. Now, rather than work in the scene view for this, I like to work in the game view. Now, if I right-click in the hierarchy and go to UI and then Text UI, the words New Text will appear somewhere in the game window. All right. You'll see text is a child of canvas over here in the hierarchy, and we have new text over here. I would like for new text to appear up in this corner. So to do that, I come over here to the Rect Transform, and I select the anchor presets. And I'm holding the Alt key on the keyboard. Notice how all of these images change whenever I hold Alt. I'm going to let go, and then I'm going to hold Alt again. So I'm holding Alt, and I'm going to select the top left block. And whenever I do that, you'll notice that new text now appears over here. Okay. I wish to change the font size to something more readable. 20 will do. And then I want to make the color black so it's nice and easy to read. All right, good. What we need to do now is to connect the ship to our new text field. So we are going to return to our code. That was my cheat sheet you just saw. We're going to return to our code, and we need to put a public variable in called public text, and I like to call this message. Now this will not work automatically. We have to add a using statement in order to get that to work. So it's using Unity Engine message.ui, and UI is uppercase. Once you do that, you can return to the update and say message.text, and that's lowercase, is equal to score colon space, and then we are just going to put the frame count. That's the dirty secret of my game. The score is just the frame count. There we go. So now, whenever we return to the game, it's going to take a moment to load that new script. Ah, I forgot something. The ship has a new public variable named message that is currently set to none. That's because we added that to our script. It is of type text. So what I have to do is I have to select the text, and I have to drag it right there. Now whenever I play the game, that error message should go away, and you can see that the score now reflects whatever the frame count is. All right. What we need to do now is to get our blocks to appear. The easiest way I have found to do this is to go back to our assets folder and enter prefabs and to create a square. Now to create a square, we are going to right click in the prefabs folder. We're going to go to create, sprites, and square. You're going to create a square, and my advice is just to hit enter and keep that square as is. I'm going to go back to my scene, and I'm going to drag my square into the scene. Now we are going to modify this square into an orange rectangle. For that, I'm going to change the scale to be 10 wide, 1 tall. Of course, it's 1 deep. I am then going to change the color, make it a nice canyon-y color. And then I'm going to add a component. We're going to go to Physics 2D, and then we're going to add a box collider. I'm not going to worry about it being a trigger, and I'm not going to add a kinematic rigid body to it. So we're just going to leave it as a box collider. Okay. I'm also going to come over here, and I'm going to rename my square Canyon, just so I can find it later. It's always good whenever you create new objects to rename them inside your scene. Next up, I want this block to fall. So we're going to add a component. We're going to go to New Script. We're going to add a canyon script. And anytime you create a new script, if you return to the Assets folder, the new script that you just created will be in the top level directory. I like to put it in the scripts folder. So I just dragged it into the scripts folder. There you go. I've got my canyon file and my ship file. So let's get the canyon script going. We are going to cause it to drop, and the canyon needs to have a speed, and I'm going to pause my video real quick. Okay, the speed of our canyon is going to be 2.5, and we came up with this number after about a half hour of product testing. So public float speed is equal to 2.5. Make sure you put an F after the 2.5. Now we're going to cause the brick to drop. And so because it's dropping, it's moving along the y-axis in a negative direction. We are going to say float y is equal to -1 times speed times time dot delta time. And now we are going to update the location of our canyon based on that new y really it's a y vector. So we will do transform dot position plus equals new vector 3 0 y 0. All right. Now whenever I return to my game, it's going to take a moment to upload that script. Check your console to make sure that there are no errors. You're going to see that the block falls. Now my game is still running, and in the scene view you see the block still falling indefinitely long after it has left the game view rectangle. That is now a burden on the resources of our game, and we need to remove it. So we can remove that programmatically. Let's return to our code and say if the transform.position.y is less than, we'll say, -6, we will then destroy the game object. There we go. Now whenever I return to my game and we play it, there we go. It fell out of view, and you'll notice that the orange block is no longer a part of my scene view, and that's because it went past -6. So 1, 2, 3, 4, 5, 6. Once it passes this line right there, it's no longer going to be part of the game, which is what we want. We don't want it to be a burden on our resources. So now that we've got our canyon all set up how we like it, what we can do is return to the prefabs folder and drag our canyon into the prefabs folder. We can now remove the canyon from our game. I'm just hitting I've got it selected. I'm going to hit the delete key. And now what we need to do is to organize our canyon edge into a list of canyons. So I'm going to create what's known as an empty. An empty is just a game object that is never seen, but often has scripts attached to it which run in the background. And I'm going to rename this game object the Canyon Manager. Let's add a component, new script. There's our Canyon Manager. Create and add. Once again, we created a new script, which I will move to the scripts folder. And now that I have my Canyon Manager script, let's bring it up. This is where the game turns into a math class. So my canyon blocks are 10 units each. And I want there to be a 4-unit gap between the 10-unit blocks. The 4-unit gap and the blocks. Each block is positioned based on the center point of each block. And so if it's a 10-wide block, where's the center? Well, it's going to be at 5. So it's going to be 5 units to the edge, and then I want another 4 blocks for the gap, and then another 5 blocks to the center of the block on the other side. So if I talk about the gap, I'm really talking about the distance between the 2 centers of those blocks. So if I want a true 4-gap block, what is the gap in programming, the programming language need to be? There's a little bit of math for you. It's going to be 5 plus 4 plus 5, which is going to be 14. So let's do public float gap is equal to 14. Let's do public center, float center. This is going to be where the center of the gap is. And then we are going to need a public game object canyon that we are going to need to know what the canyon looks like in order to instantiate it. All right. There's one other tool that I would like to have, and this is purely a trick in order to keep track of the number of blocks that should be in the game. The number of canyon pieces that you see on the screen at any one time is a constant. Now, blocks are constantly getting removed as they drop off the screen, and so we want the manager to say, if 2 blocks fall off, add 2 more at the top. And so we're going to do a count of that. So public int canyon edge count is equal to 0. Notice that's an integer instead of a float. Let's do a for loop for float y is equal to -4, y is less than 6, y plus plus. So what that's going to do is it's going to create a for loop where y is equal to -4, -5, I'm sorry, no, I'm going the wrong way. -4, -3, -2, -1, 0, 1, 2, 3, 4, 5. All right, so that was 10 iterations, and I want to put 10 blocks on one side of the screen and 10 blocks on the other side of the screen for a total of how many blocks? 20. So we are going to do what's called an instantiation. So we are going to instantiate. There are 4 parameters that you need to know for instantiate. The first one is, what are you cloning? So we're going to create a canyon piece. The second parameter is, where are you going to put it? So we're going to do a new vector3, and I'm going to take a moment and look at my cheat sheet. So pause. All right. So there are 3 parameters for the vector3. That's the x, y, z. The x is going to be the center minus our gap divided by 2. The y is going to be at whatever our float y is for our for loop. There's the float y right there. And the z is going to be 1. The third parameter is how you wish the object to be rotated, and we want all objects to be rotated essentially none. But there is a tool. I'm going to pause my video again. All right, so the third parameter is called the coordinate identity. It just means orient this particular block based on how the parent is oriented. And then the fourth parameter is, who do you want this to be a child of? And we want this to be a child of the canyon manager. And the what you have to pass in is transform. All right. So before we move on, let's just play with that line and run with it and see what happens. All right. Before you test out your code, you need to make sure that the canyon manager knows what a canyon piece looks like. And so I'm going to select the canyon manager. I'm going to go to Assets, Prefabs, and then we're going to select Canyon Manager again, and then drag the canyon to the Canyon Manager. And hopefully, there we go. There is our canyon going down one side of the screen. Great. We are going to do this again. And we are going to say, instead of center minus, we will say center plus. Now whenever I play the game, I now see 2 canyons go down the screen, which is what we want. Great. Now, after those canyons, after that introductory period has passed, we want the canyons to start moving. Here, I'm going to have to get off Twitter. Here is where I feel it's helpful to get a little bit of math. My blue line represents the location of the center. And so I want the center to start at 0 over time, go as far as +5, get as low as, it's right about there, at almost -5, return to 0, and then go on this loop between 5 and -5 forever. And that's going to be our center. Where was my 0 coordinate? Did I go too far for 0? There's my 0. So let's program the center. Now I'm going to return to my code. There's one other thing I want to do. After we have those two blocks created, I wish to do a canyon edge count plus equals 2 to signify that we have, sorry, just punched the camera in the face, to signify that we have 2 edges. Next up, we are going to do an if statement. If the canyon edge count minus the number of children. So we're going to say transform dot child count is greater than or equal to 2. I want you to create 2 more edges. Now if I just grab these 2 lines right there, and I'm going to replace these with this y variable there. I'm going to replace that with we'll say 5. In fact, let me check my cheat sheet. 4. We'll do that with a 4. There we go. We will save that. Let's run our game. And you'll see that we have a constantly generated edge to the sides of our canyon forever. And if I go to my scene view and I back up a little bit, you can see what's going on. All right. So let's return to our code. Let's program in the center. The center is going to be, and I use it on my formulas here, sine times 5 times the sine of whatever the frame rate is divided by 240. So 5.0f times mathf dot sine transform, oh no, it's time dot frame count divided by 240. And make sure you do 240.0f. So now whenever I do that, I'm going to run my game. And the center should move back and forth. There we go. Our center is now moving. But something else that I would like to do is to get the gap between the 2 edges to change as we play the game. And that's why I have the second formula, the cosine x divided by 60 plus 16. I came up with these formulas prior to the game. So that's our gap. We will do mathf dot cosine time dot frame count divided by 60.0f plus 16. And there we go. Let's play the game. You see that we start off with a fairly large gap, and then the gap will get narrow at times, and then the gap will get wider at times, and it just depends on where you are in the chain. All right. So that is our game, except we can still pass through the blocks, and we want the game to stop whenever we pass through the blocks. Oop. For that, we return to our ship, and we write a new method. Now remember earlier in the video I said you should add a trigger to the ship, and this is where that comes into play. So void on trigger enter 2D, we will destroy the game object. All right, so we're going to destroy it, and that's all we're going to do. Oop. And let's play. So now the game is going to begin, and I'm going to run into the side. And you'll notice that as soon as I ran into the side of the wall, the ship was destroyed. There's no more ship on the game, and our score stopped at 704. And so we can see where the score ended. And that is our game. Now you could take this in a number of directions. You could speed it up. You can play with the mathematics and change with the gap. With the gap entries, you can change the color on the canyons. You can have some fun with this. So I feel like there's many avenues for creativity where you can let the students just roll with it.